Hello all, and welcome to your last lecture of Intro to Calculus. It's been such a pleasure and a privilege to get to work with you. Obviously, I'll talk to you a little bit more over Zoom as we close out this year, but I just wanted to let you know at every opportunity just how proud I am of you and how much I have enjoyed the chance to work with you, even if it wasn't necessarily the class that we all imagined it would be. So what we're going to do is we're going to finish up 9.3. You'll have work day for the rest of the week. Your last quiz will be this Friday on May 21st. And then for the last 2 weeks, opportunities to catch up on missing work and corrections, as well as a Zoom session with me, at least one, to talk about maybe prioritizing some of those and to discuss your next steps in mathematics. So, can't wait to talk to all of you. Let's look at our last lesson. So we're still talking about separation of variables, but as I said, we're going to now add in a final step, which is just to solve for c. So we're going to do the same thing that we were working on in our last lesson. We're going to separate x and y, integrate both sides, then solve for y, just like we've done before. And now we're just adding in this final step. So here, find the solution. We start with dy dx is equal to 2y, where y of 0 is equal to 10. So we're going to start the same way. There's no x term here. So what I'm going to do is I'm going to multiply by dx. So just similar to what I did for the first problem, and then divide over the y so that we have 1 over y dy is equal to 2 dx. Even though we don't have an x term, we want to still separate our variables because this doesn't match here, so we need to use separation. Integrate both sides. 1 over y, the integral is ln of y. The integral of 2 is 2x, and then plus c. So when we solve for y by itself, it's e to the 2x plus c. Like so. Now we want to take our last step, which is to solve for c. Now we're given this initial condition, which says that x equals 0 when y is equal to 10. So we're going to just take that and plug it into our function. So 10 is equal to e to the 2x, and x is equal to 0 plus c. So 10 is equal to e to the 0 plus c, which is just c. So c by itself is the natural log of 10. Now, if you just write, so then y is equal to 2x plus ln of 10. Now, as I said, you'll often see problems with this, with e to the x like this, written slightly differently. And the reason for that you can imagine in this case, is that the e and the natural log can simplify, but the 2x can't. So I'm going to write this as e to the 2x times e to the ln of 10. Separate that added exponent out into two terms. Now the e and the natural log can simplify. So we get e to the 2x times 10, which is how you get what probably would be in the back of the textbook, which is y is equal to 10 e to the 2x, just a nice exponential function. All right, last example, number 2, dy dx is equal to y cosine x over 1 plus y squared. So the first thing that I'm going to do in this case is I am going to cross multiply, and I get 1 plus y squared dy is equal to y cosine x dx. Then I want all my y's together, so I'm going to divide both sides by y, and I get 1 over y plus y squared over y, which is just y, dy is equal to cosine of x dx. So again, cross multiplied, divide by y, divide this term, divide this term. Then integrate. And what I end up with is ln of y plus 1/2 y squared is equal to negative sine x plus c. Now, here's an important note, and this will sometimes happen. You can't solve for y here because they're two different types of functions. Right, we have a log and a polynomial. If that's the case, you can just jump straight to the plus c and you'll leave it as a larger function. I'll show you what the final answer should look like. So can't solve for y, so jump straight to solving for c. Here we know that when y is 1, so natural log of 1 plus 1/2 1 squared, then x is equal to 0, plus c, like that. ln of 1 is 0, plus 1/2 1 squared is 1/2. Sine of 0 is also 0, plus c. So then c is equal to 1/2. So the way that we'd write our final answer, we're just going to use the function at this stage as ln of the absolute value of y plus 1/2 y squared is equal to negative sine of x plus c, which is 1/2. So if you can't simplify any further, that's fine. Just leave it in as simplified of a form as you can. If you have any questions about 9.3, or of course anything about the course, please be in touch.